Cool. So, hello everyone. Thank you for coming to this workshop. This workshop will be on the Flare data connector and specifically how you can get any Web2 API data onto the Flare chain. The way this presentation is going to work is we'll have 20 minutes of presentation followed by 8 minutes for Q&A. So if you have any questions, do save them for then. So I'll first explain how FDC works really briefly. I'll go through how the user workflow is supposed to look like. And in the end, I'll also just briefly mention how you can modify the existing code on the Flare Hardhat Starter repository so it can serve your own projects, or rather so it can serve as a baseline for your own projects. But before we get started, I would first like to mention that there's the Flare Developer Hub. And Flare Developer Hub is the go-to place if you need additional written guides and overviews of our technology. More specifically for the Flare Data Connector, you can go under FDC, FDC Guides, and Hardhat. And there is also a more expanded guide, which basically covers all that I'm gonna talk about today. So, first of all, let's look at this diagram here that explains the user workflow for using the FDC. So, first of all, let's say you're building a DApp that needs some external data to function. For example, you could be building an insurance agency that needs weather data to resolve insurance policies that rely on that weather data, which, by the way, is a guide that I have written, so you can look at that in your own time. But anyways, the diagram here demonstrates what the user workflow looks like. First, you have some external data that you need. The first thing you need to do is create an attestation request to the FDC protocol. And the attestation request is submitted as specifically encoded byte string. And you could, of course, do this manually, but we have a verifier server that can do that for you if you just provide it with the with string data that basically matches the attestation request. Once you have that, you submit the attestation request to the FDC protocol through the FDC hub contract, which lives on the Flare chains. And then you need to wait for the voting round to finalize. So the voting round finalizes in at most 180 seconds. It's usually much faster. What will happen in that time is the validators of the Flare network, which we call data providers, will go to the URL that you have provided, get the data, apply the JQ filter that you also will need to provide, and then encode that as a Solidity struct. They will also hash the data, and then with consensus write the hash onto the Flare chain. So at that point, the round will have finalized, and you will be able to go to one of the data providers, one of the validators, and request the data from them. And then when you get the data back, you will basically be able to do the same thing they did to get the Merkle proof and compare that to the one stored on chain to see if they tried to deceive you or they in fact gave you the correct data. And at that point, your data is basically free or good to be used on the Flare chain. So that's the overview of the user workflow. The user workflow is encapsulated within the Flare Hardhat Starter repository. This is a repository that's available on GitHub. So let me open that up really quickly. So the Flare Hardhat Starter is a good baseline for your projects because it's basically functioning code. I have already cloned that and basically copied the example environment file to the environment file. And now let's look at we don't have okay, first of all, let's look at the contract that we will need. And this one is under contracts and FDC example Web2 JSON. The other contracts within this, or the other files within this folder, are all different examples for different attestation types. So what this contract does, it simply goes to, it simply takes an input of a Star Wars character and saves it to a list. So a very, very basic thing. What is more interesting is the script that actually goes through the whole of the user workflow. And the script is saved in scripts, FDC example, and Web2 JSON. So I will run the script so it goes off in the background while I quickly explain how it works. So if I scroll down to the main function, you can see that each of the functions here corresponds to one of the steps in the workflow that I have described. So we first of all prepare the attestation request. In this step, we get the data that we have predefined and basically make a GET request or a POST request to the verifier server, which gives us back the ABI encoded data. With that ABI encoded data, we can submit the attestation request to the FDC Hub contract. And then we have to wait for the run to finalize, which basically happens within the retrieve data improve function. And with that, we can get the data improve back. We can also then deploy our contract, the Star Wars character list that I briefly showed. You could just as easily access a static pre-deployed contract at this point, and then we interact with it by giving it the proof. So if I open up the terminal, we can see that first of all, the request was prepared. This was the data we inputted, the URL, the JQ filter, and the ABI signature. And the ABI signature is the encoding of our Solidity struct. And I will show you how you can get that in the simplest way possible. We see that the data we provided was valid. This is the ABI encoded request. And we submitted that to the FDC Hub contract. This all happened in the voting round with the ID, with this ID basically. And then we also got back the proof, so the proof is constructed from, first of all, the hex encoded response. This is where our data is, and then the actual proofs that we need to check. And lastly, we deployed and verified the contract, inputted the proof, and the Star Wars character we were looking at was R2D2 with the body mass index of 34, if anyone was interested. Let's now briefly talk through all the components of the request, or at least the most interesting ones. You can see that they are defined right at the top of the example script. Um, there is a thing commented out because the API stopped working, so we are temporarily using the Star Wars API.info instead of .dev. And I mean, this is simply an API that gives you Star Wars character information. No need to spend too much time on that. What's more interesting is the post-process JQ. This is basically the JQ filter. And the most, like the easiest way that you can workshop that is to go to a website like JQ Playground. And this is a website that basically allows you to live perform the JQ filter on input data. And let's see if I can get some real data real quick. And I think that the easiest solution is to just go to the Star Wars API, and this will require some bending on my part. Okay, perfect. So let's take the Luke Skywalker data and just copy all of that into the JQ Playground. So what we can now do is stuff like that. So we could like get the name of the character, and this would be, we would first of all have to take the first element because I copied the thing weirdly, and then call the dot name to get the name field. But we would also be able to do some simple transformations, which in this case, let's see. Yeah, let's take height, and that would be again 0 field height. And we can also apply transformations like to number. And I possibly need to enclose this. Let's see. Anyways, look at the documentation for that, basically. So anyways, this is the second part, the JQ filter. And the last thing you need is the Solidity struct, so the API signature. And this is how the data that you get back and filter should be encoded. And the easiest way that we found of doing this is to basically defining a mock or a placeholder function within a contract. So if I open Web2 JSON file up, you can see that there is a data transport object struct at the top of the file. And I'm defining a function called API signature hack, which takes the data transport object as one of the parameters and does nothing. But what this allows us to do is to then compile the code, go to the artifacts, contracts, FDC example, Web2 JSON, and then it takes a bit of looking to find the API signature hack function within the API signature of the contract, and we can see that among its components is the API signature of the data transport object struct, and this is the thing that would be inputted into the script. So with 5 more minutes, let me just quickly point out the places where you can modify the existing script or existing project to serve as the baseline for your own project. First of all, you of course need to define your own contracts, and the only thing that contract needs to do to be able to work with FDC is to get as a parameter a iWeb2JSON.proof parameter as input, and all you need to do with this input is to first of all validate it, and you do that as it's shown here through a FDC verification contract. And then you, of course, decode the data into the data transport object, and afterwards it's up to you what you want to do with that data. So that's the first modification that's needed. The second modification is, of course, providing a new URL, which is the URL that you would be using. Then the third modification is the JQ filter that you're applying. The fourth is the ABI signature, which should match the data transport object that you define. And then there are only a few more modifications left. Namely, you need to deploy your contract either in this script or in a separate script. And then you need to access the contract here, of course, and interact with it. And the interact with contract script, function, is the one you would be modifying to accept the input that matches your contract, and of course calling the function on that contract. And so these are all the necessary modifications to get the project working with a simple one contract example. But there are, of course, much more complicated things that you can do. And I recommend that you look at the other guides for inspiration on that. But with that, I think I'll conclude this. If you have any additional questions after the Q&A, visit at the booth. But yeah, now we have 10 minutes for questions. So yeah, a question right there. I think he will bring you the microphone.
Thanks a lot for your talk. I see I saw you use proof. Is that like Gross 16 proof, or is that anything signature or something like that?
Yes, so the proof that we use is basically just a custom struct that we have defined. I mean, it's wait. The question was is it a ZK proof? It is not. It's it's a simple struct called a proof because it has it contains an array of Merkle proofs that can be cross-checked against the data so that the data is valid, but it is not a Merkle proof. I can open up the proof, the proof struct itself. It's basically, it has an array of Merkle proofs and a response struct, which again contains the attestation type, source ID, request body and response body, and data is stored within the response body. Cool. Another question there.
Hey, for the data connectors, can you embed API keys or like sensitive information when you make some API calls to external data?
So the question is, can you embed sensitive information within the data? The answer is no, because, the answer is yes, but probably not. So you could do that, but once you perform this whole attestation request thing, once you get the data through FDC, it becomes exposed to public. So at that point, it's not private data anymore. So you could do that, but you would basically destroy the data that way. Yeah. Any more questions? Cool. Yeah.
You mentioned you have write up or an example of how to get the weather data. Would you like to show that?
Sorry, I didn't catch the question.
You mentioned you have the write up or example of how to query or get the weather data. Can you show that?
Yeah, I can show that. So the question was about the weather data I have mentioned, right? Cool. So if you go to the first under contracts, there's the weather insurance, which has two subfolders. I'm looking at the wrong thing. I'm right. Cool. So if you go under weather insurance, there's mean temp and agency. Basically, this defines a simple insurance agency which allows you to create a contract with specific coordinates and the minimum temperature threshold. And so if you provide a proof that the threshold was exceeded, it is considered that the loss has occurred. The more interesting thing is probably the script that does that. I mean, that interacts with that. So if we go under mean temp agency, there are first of all scripts to deploy the agency itself, scripts that allow you to create an agency, to create a policy, claim a policy, and then resolve the policy. And so let's quickly look at the create policy. So create policy contains the latitude and longitude of a real place in Slovenia. What I first do is go to make an API call, because that thing contains the coordinates of the nearest weather station, and I want to create a policy that uses those coordinates instead of these ones, so that I can cross-check it with the response. And then I simply create the policy, and for the policy resolution, it is again an API call to open weather with the JQ filter and the API signature. And what's interesting here is that the API requires a key, which is free to get, but you still need to provide it somehow. And let's see if I can find it real fast. Basically, the Web2 JSON attestation type allows you to also input query parameters. And so I'll just query. So prepare query parameters. Basically, I'm passing in latitude and longitude as well as the API key as query parameters. And I just basically doing a JSON stringify that. And the query parameters will be passed in as basically a field in the request body, and then the backend will be able to construct the correct URL to correct API call using that. So that's just a quick preview of it. But there's also a guide on the Flare Developer Hub. If you go under FDC guides, Hardhat, and weather insurance. And this goes much more into detail about it all. I think we have enough time for just one more question if anyone has it. If not, or if another question appears, I invite you to visit us at booth. It's like we have a nice view of the main venue, so you can find us there, and we'll be happy to answer any and all of your questions. But otherwise, thank you for coming to this workshop.